We're going to start now talking about graphic functions in version 3. And there are essentially three main core topics that have been released with version 3. One is the Desigo PX graphics generation tool, similar to Dig, like in Desigo CC, Desigo Insight, excuse me. So we'll have a look at that. We'll demonstrate some of the functionality of that a little bit. Then we have, which was something that was highly demanded by the Fire division, Fire people, which was in-graphics commanding. So the ability to have a graphic symbol on a graphic page and directly command from that symbol, rather than having to use the operation pane, rather than having to use the status and commands bubble. So this we have now implemented in version 3. We'll have a look at that in a bit of detail. We want to look at the AutoCAD import tool. It's been enhanced with some additional functions, operations that make it maybe a bit more usable and a bit more flexible. So we'll look at those aspects as well. So those are the three main topics. For the benefit of our viewing audience, I will maybe go through these first thing in the morning when we're all fresh. I'll show you each of the topics individually, demonstrate them a little bit, and then the last hour we can then go ahead and do the exercises. Normally I would split it up, but just to have the continuity for the live stream, might be better just to show the theory, and then they can leave if they need to, and we can concentrate on the exercises. I hope that's okay for you. Okay, let's get into the topic, see what we're looking at. There's some, I'm going to show you some information in the online help anyway, but let's have a look first at the Desigo PX graphics generator. So what we have now is this ability to take our structured programs from the PX system, plants, partial plants, this type of thing, and use a conversion tool to convert this information into graphic pages. That's what I'm showing here. It's really a drag and drop effort from the engineer. He takes a selection of plants, partial plants from his PX system, drags it into the graphic generator tool. Then he makes some decisions about what type of symbols he wants to use, maybe about what type of mapping variant page he wants to use or she wants to use, and then hits the generate button and waits a few seconds and then has a series of graphic pages. Well, we're laughing, we say a few seconds, could be a few hours, we don't know exactly. All depends on the number of graphic pages. I believe in the UK they did a test with 1,500 graphic pages, don't quote me on that number, but 1,500 graphic pages, and they were generated in 50 minutes. So I think it's quite an efficient tool. Okay, so that's the basis. Very simple, but the decision making comes in determining what information you want to give the graphic generator before you actually generate the graphics. And this is just a brief workflow. So the first thing we can do is let's go right into the system. Have a look at this workflow and just follow it through, and I can show you by example some of the functionality here. Okay, so first of all, we have to know where the graphics generator is at all. It happens to be in the management view. And there's a node under the system settings called conversion tools. Under that, you'll see Desigo graphics generator. On Friday, you'll see that there's another conversion tool in this node for Desigo Insight graphic migration. So we actually will have by the end of the week, two conversion tools available to us. One to convert PX graphics, the other one to convert Desigo Insight graphic into a Desigo CC format graphic. Okay, so two different conversion tools. Now, like all things from HQ, this tool is assuming that we're using the CAS libraries. It's exactly like we did in Desigo Insight. We said we can use this tool efficiently, but it's based on the CAS library from the HQ delivery. Now, if there are adaptations that have been made in the zone or countries using elements from the libraries, but adaptations of it, then we can also adapt the background mapping pages and symbol variants that we use to generate these pages at the library level. So a librarian would come in and say, okay, this is our library that we use in the region or the zone. I'm going to adapt the mapping pages, the variant pages for the regional requirements or the zone requirements. And then we can quite as well use this tool for those purposes as well. Just to quickly go down to security settings, just to let you know that is an application rights setting that will allow us to use the tool. Go into administrators, and if we come down to graphics generator, there's a flag set for that, and it's basically a show function. So graphics generator show in the application rights, that will enable the snap-in, and we should be able to generate our graphics. So here's the snap-in, Desigo graphics generator. It's a blank page. You can see there are different columns here that we're going to end up using to adapt our system for the page that we want to generate. And let's go ahead and take a look at what we can do here. I'm going to go into the logical view, which is the normal place where we go to get our graphics, because we have the structure there in this view from the import file. And let's take a couple of plants over to the snap-in. Something like this, for instance. Here we have two different air handling units. We can see now that things have been activated here. For instance, mapping page filter. Let's see what it shows us. What it gives us is the option of which symbol set that we want to use to generate our graphics. So if you remember from maybe the advanced course, or if you've done any research into the whole graphics aspect, you'll know that the symbols in our libraries are defined according to these symbol styles: 2D, 2D+, 3D, 3D-EN, 3D-EU, 3D-NA. There are many different types of symbol styles that we're using here. And before we generate the graphics, we have to decide which particular style we want to use here. It also applies to static symbols. So if I select 2D DIN or 2D gray, the DIN part is standardized, of course, for also the symbols, but also for static elements like piping, ductwork, this type of thing. So we could say 2D DIN, which is now applying to all the nodes here that I'm selecting in this generator. So I don't have the ability here to say, oh, for this particular node I want one style, and for this particular node I want another style. If I want to do that, then I have to drag and drop individually, the instances individually, and then generate the graphic. But let's decide on 2D DIN. What else can we do? Another thing we can do here is filter the mapping variants, the mapping page variants on discipline. So you know that from the past, hopefully, that each object instance is classified according to type, subtype, discipline, subdiscipline, etc. So let's set the discipline to air. The system, the generator, has already chosen for us a mapping variant. So I've already seen for this particular L10 air handler, if I roll over, I see a thumbnail image of the mapping page, and the system, if first in the list, is the preferred, or what the system considers the most close match between the plant data that I've given it, that it's reading, and the mapping page. So it assumes that this CAS 50 is, CAS HU10 is the probable best match for this particular plant. Down here, it's assuming that also CAS HU10, but another mapping page is the best choice here. So we'll just leave it for now, see what it gives us. Then I have this field options, and you know when we do drag and drop of a heating cooling circuit, we don't get all the piping assemblies, we don't get the valves, we have to really manually engineer the circuits, cooling circuit, heating circuit, to adapt to the physical plant that we're using. The system doesn't know that by drag and drop, which particular assembly we're using. So we have to tell the system what it's going to look like. And we have to do the same thing here. So we can say, for instance, the cooling circuit is an injection circuit or a mixing circuit. The preheater, injection 2 ways, mixing, etc. And the reheater as well. So we have 3 different possibilities for these circuits. I'm going to just leave them on the default at the moment. Now we can say, let's name this particular graphic page. What are we going to call it? Why don't we just take this particular, it's suggesting a name for us already based on the structure in the logical view. But let's just take this prefix away and maybe just generate them as such. So I got building C, NAL10. And I'm just going to store it in the parent graphics folder. I can also create a folder structure prior to generating any graphics. And then this, of course, this context drop-down menu will give me the graphic parent node as well as the different folders. So I can organize my graphics right here from the graphic generator. Now, let's have a look at maybe while we're here. Maybe we want to set up heating generation. So let's take, what do we got in here? I would like to do something maybe heating group. Set up a couple of heating groups. Got one here. And maybe take this heating group. So I've got 2 heating groups, for instance. And let's have a look here. These are heating. Oops, sorry, cooling, heating, heating. I'll just leave the defaults here. You notice that when I enter sort of a similar, let's say, plant or partial plant, the system is saying, do you want these on the same page? So we have the option of saying, I want to put these on the same page. And you can see here I can set a position, group position 1, group position 2. So what I expect to see now is the generation of this graphic with these 2 distribution loops sort of connected together by the piping schematic. Position 1 maybe on the left, position 2 maybe on the right. And then I can say, go ahead and generate these on the same page. Maybe we'll just take it from here, Control C, Control V, into our graphics folder. So I'm saying, put these in these 2 positions on the same graphic page. So that's about all we need to do really to get the initial results that we're looking for. So let's go ahead and generate the graphics. It says once the generation has started, it cannot be interrupted. So to avoid any issues with corrupted data, corrupted graphics, whatever, we have to sit back and relax for a few seconds. You can see the status is changed to in progress. And while it's thinking about what it's doing, eventually down below in the lower status bar of the client, we'll start to see these graphic pages being generated. So we can already see now it's generating the first graphic page. There's a nice status bar here giving us some indication about what's going on. And I would suspect probably in about 2 minutes we should have these 3 pages generated, maybe less. Okay, so that's the main rundown. While this is working, let's have a look in the documentation just to explore a little bit about how the graphic generator is actually working in the background. So as I said, here's some interesting information. A couple of questions about what is this graphic generator actually doing. And what it's generating is static symbols and the corresponding graphic symbols with the object reference. Important is the object reference because obviously we need to make a link from the symbol to the object. When we do normal engineering and we do a drag and drop of a object onto a graphic page, the graphic engine automatically selects a symbol for us and places the object reference into the object reference field of the symbol, and then at runtime the link is made and we show dynamically the current state of that particular piece of plant that is represented by that symbol. And this is doing the same thing. So it's placing symbols. Placing symbols, I mean selecting the correct symbol based on the application name or the short name of the particular object or objects that are in that plant structure. So the application name is driving which symbol we're using, or the object reference, and the function name is driving where it's going to be placed in the schematic. So if I have a fan with a fan SU, fan supply, function name, it means place it in the supply air duct, not in the extract air duct, for instance. So that's what we're doing here. Now, we're going to see the result. Of course, it may not be one-to-one the result that you expect. Maybe there's some placement issues. Maybe you have to move some elements around to get the exact result that you're looking for. But generally, we want to have a, let's say, a uniform result for all the graphics. So we're using the same symbol sets. We're using the same positioning, the same sizing, the same resolutions. All these things are being done by the graphics generator for us. So it creates some uniformity in the look and feel of all the graphics and the operational side as well. I mentioned that you could, here's an example of a ventilation plant mapping graphic and showing how it's built up. So we have the application name as the object reference, and we have the function that shows in which position all these elements are being placed. So you can see just from this particular drawing, if I want to move the supply air fan, where at the moment it is placed behind all the heating and cooling circuits, which anybody who knows HVAC would say is probably the wrong place. Normally we want to have the supply fan before all the heat, after all the heating and cooling circuits, because it's drawing the heating or cooling air through and then supplying it to the space, of course. But here, probably for reasons I assume of purely the space that we have available for us on that duct to place symbols, it was put in the last position. So we're going to see a plant that looks like this, and you may say, no, obviously this doesn't make sense. I have to physically make an adaptation on the drawing, move the heating circuit, cooling circuit back, and bring the fan forward on the duct. Now you might say, that's a single instance only on that graphic page. So I would have to do that on every graphic page that's using this mapping variant. A better way is to go in here and customize or edit the mapping page and make it available to everybody so that it is in the distribution and with all the correct positioning. This is the better approach in this case. So that is an example of all the various application naming on this one graphic page. On the symbol side, there are also symbol variants that are built into one page. So if you go to, for instance, a fan variant symbol, here is the basic fundamental symbol for this 2D fan. But you can see here, this particular graphic page contains layers. And each layer is associated with a different function name, which corresponds to the different type of fans that are provided in the PX library. So by taking a fan variant and saying you have a particular function for it assigned to this particular fan, you will get the appropriate symbol just by turning on and off the layers. So the graphic generator is just enabling the layer that's associated with the function fan 1 stage, and the other layers won't be visible. So you just see that one symbol. So that's that fan variants are built up, or symbol variants are built up. Okay, let's have a look now. So we have 4 plants selected. Generation completed in 1 minute and 33 seconds. Let's take a look in the application view. There's our first plant graphic. Manual navigation, plant graphic for the first air handler. Again, notice the fan is pushing air through all these circuits here. Doesn't really make sense, of course, but that's a positioning issue that you would have to take care of. Sorry? Yeah. And here's the heating groups. remember I said I want to use the same graphic page, position them accordingly, position 1, position 2. So we have these two heating groups linked. Now I'm not saying they're from different plants, may not be relevant at this point, but just to show you what the result is when we use the positioning option and we name the graphic page to the same graphic page for both of these particular plants, they will appear on the graphic page in the assigned positions. So that is the graphics generator in brief. I told you a little bit how the mechanism behind it works with using the application name, the function name to provide not only the correct symbol but also the placement, positioning inside the plant structure. And there we have it.